Very good. Kau dah lama ini lari, mata ikut dah balagan namda nabo. Ikan ada ni, no. Kalau dah hendak ni tu bangkit. Oli na ino apa? Hari ni ikan ada ni, no. Hari Sachin ino. Kalau dah hendak ni tu bangkit nanti. Dan board dekat halin tu ada. Pena ni, pena ada board dekat. Board dekat pena ni lah mai. Biduna. yes hari hari එහෙනම් අපි කරගෙන යමු අපෝ sorry for the interruption මම දැන් router එක නැතුව මේ phone එකකින් streaming එක දෙන්නේ වෙනදට වඩා පොඩ්ඩක් quality එක අඩු වෙයි අපි කොහොම හරි පන්ති කරගෙන යන්න ළමයි අදට මට හෙට නෙමෙයි අනිද්දා මේ පොයනේ අනිද්දාට තමයි මේකේ මේ වැරද්ද හදාගන්න වෙන්නේ එතකන් classes කරගෙන යන්න වෙන්නේ මේ විදියට එහෙම කියලා අපි නිකන් ඉන්න ඕනේ නැහැ පුළුවන් විදිහට කරගෙන යමු right so the definition given a function fx some function fx its derivative is denoted by f dash x and it is defined by f dash x equals limit as delta x goes to 0 limit as delta x goes to 0 f of x plus delta x minus fx over delta x, right? This again gives some function. So it is that function we call the derivative of fx and we denote it by f dash x. Now I know that just seeing this you don't get much an idea, but things will be very clear after we take one or two examples, right? The first example, to find the derivative, right? You have to find the derivative. The function is fx equals 5x plus 3, right? 5x plus 3. So you have to find the derivative. So we start by, if you have to find the derivative by the definition or by the first principles, we start by writing the definition. So f dash x is defined by limit delta x goes to 0, f of x plus delta x minus fx over delta x, right? Now I am going to substitute in this. මම මේ ලයින් එක ආපහු මකලා ලියන්න. මම හිතන්නේ ඔයගොල්ලන්ට බලා ගන්න බැරි වෙන්නේ නැති. Equals limit as delta x goes to 0 delta x goes to 0. We first substitute the easy ones, easy things. First, I substitute for delta x. So delta x will stay as delta x, no change. Delta x in the denominator it will be the same delta x, right? Then here you have fx. So what is this fx? Fx is given, it's 5x plus 3, right? So fx is 5x plus 3. So for this fx I'll substitute 5x plus 3. 5x plus 3. Then f of x plus delta x. So what is this? F of x plus delta x. That's what I was explaining when we had some introduction. Here fx is 5x plus 3. So here we want to substitute f of x plus delta x, right? So f1, if you want to find f1 will be equal to 5 into 1 plus 3. If you want to find f1, you will replace x by 1. f1 equals 5 into 1 plus 3. So you want to find f3, you will replace x by 3. f3 will be equal to 5 into 3 plus 3. So likewise, you will find f of x squared, the composite function, f of x squared. So you will replace this x by x squared and that will be equal to 5x squared plus 3, right? 5x squared plus 3. So you want to find f of t that will be equal to ft will be equal to 5t plus 3. So you want to find f of 1 of x, you will replace x by 1 of x. So f 1 of x will be equal to 5 into 1 of x plus 3. So likewise, so we want to find f of x plus delta x. So we will replace this x by x plus delta x. So that's all you have to do. Replace x by this x by x plus delta x. So that will give 5 x plus delta x plus 3 and minus 5x plus 3 divided by delta x. I write it again. Intermediate limit as delta x goes to 0, 5 times x plus delta x plus 3 minus 5x plus 3 5x plus 3 divided by delta x, right? 5x plus 3 minus delta x. Now look at this and see what you notice here. This plus 3 and minus 3, they get cancelled. So will 5x and this minus 5x, they get cancelled. Right? Now in the numerator will remain only 5 delta x. The numerator will be just 5 delta x and the denominator is delta x. So now we have f dash x equals limit as delta x goes to 0, 5 delta x divided by delta x, right? 5 delta x over delta x, and you see now this delta x, you can cancel that get cancelled because now remember that many times we wrote in our lesson of limits, we want to find what happens as delta x goes to 0. As delta x goes to 0, not at delta x equals 1. You remember, finding the limit at delta x equals 0 does not mean anything happening at delta x equals 0. We just want to find what happens as delta x gets closer to 0. So it's not equal to 0. So saying delta x is not equal to 0, you can cut these things. They will get cancelled. Okay, if delta x is equal to 0, you can't make things disappear like that. So anyway, so delta x disappears, leaving only 5. Now you can take the limit, right? Now you can take the limit. So wherever delta x goes, it will stay at 5 because delta x disappears. So the limit is, finally, when you take the limit, that will give just 5. So it is 5. And this is the derivative. So it's equal to 5. So f dash x, for this particular example, fx equals 5x plus 3, this particular example, f dash x will be equal to 5. For this particular function, for f dash x, we get only a constant, but not always, right? Not always. You will see in the next example and the examples after that. So it's some function. It's some function of x. For this particular example, only you get a constant, right? Constant function. I think you got some idea, right? A little idea with this first example, but let's do a few more. Then things will be very clear. You just take it down, and we will go to a few more examples. Just take it down with the examples. After that, we can see more examples, right? Correct. Right, if you have finished copying this, you can go to the second example. You have to find the derivative of x equals 2x squared plus 3x minus 1. Balance කරගෙන යන්න බලන්න. Here the second example, fx equals 2x squared plus 3x minus 1. So you can try that. And then I'm going to try to start by writing the definition. Anybody finished can display your answer. If you finish, display the answer. Numerator is delta x and 2 times x is replaced by x plus delta x squared plus 3 times again x is replaced by x plus delta x minus 1 then minus our fx is this 2x squared plus 3x minus 1. Right? So even at this stage, you see some terms getting cancelled. What are them? Here is minus 1. Minus 1 is cancelled. And 3x. So it's 3x. Then, yeah, I'll write the remaining terms for the moment. So I'll have to expand this before simplifying further. Limit as delta x goes to 0. I'm going to expand this 2 times. පොඩ බලා ගන්න ළමයි මෙතන වැරද්දක් එහෙම කරාද කියලා. Squaring it, you get x squared plus 2 times x into delta. 2 times x into delta x. 2 times x into delta x. Would you write it as 2 like delta x squared? එහෙම ලියන්න පුළුවන්ද ළමයි? Is it correct to write this as 2 delta x squared? No, it's wrong. So 2 delta x squared is 2 delta x into delta x. 2 delta x into delta x. So but here, what we have here is the 2x into delta x, right? We have to write it like this. It's not this. And what is the next term? The expansion, the next term is square of delta x. So it is delta x square. And that's what I get expanding this. So the remaining 3 delta x minus 2x square. Divided by delta x. So again you see some terms get cancelled. Number 1 is x square. Not just that. 2x square, the term gets cancelled. And leaving limit as delta x goes to 0. In the numerator going to remain here 4x delta x and 2 times delta x squared plus 3 delta x plus 3 delta x divided by delta x. So these are the terms remaining, and look at this closely. So did you notice anything? Yeah, it is that delta x is common in the numerator. So delta x is everywhere in the numerator, and denominator also there is delta x. So delta x delta x will get cancelled from all the terms because it is common everywhere. So it will get cancelled. This delta x, here that delta x, this delta x, and this. So finally leaving as limit as delta x goes to 0. I'll give 4x here plus 2 delta x plus 3 as delta x goes to 0, right? So delta x goes to 0. When you take the limit, now you can take the limit. When you take the limit, this term will disappear because delta x is there and that will go to 0. So finally leaving 4x plus 3. 4x plus 3. And that is the derivative. So the answer f dash x is equal to 4x plus 3 for this function. දැන් කලින් වඩා අදහසක් එන්නේ නැතිනේ නේද? හරි, තව එකක් දැක් කරමු. You can finish this and like the third example. And we will calculate another. Number 3 x cube plus 2x squared plus 5x plus 2. Third example, fx is x cube plus 2x squared plus 5x plus 2. You have to find f dash x. කරගෙන යන්න ළමයි. Right, I'm going to write then the remaining terms directly. If you have done, you can just check, right? Uh, when you expand this, here you can see some terms getting cancelled, especially this 5x and 2. You can already see they are getting cancelled, and so will the x cube term that you get when you expand this. So you get an x cube term that will also cancel. So the other three terms of this expansion will remain, right? It will remain. So the other three terms are 3x squared delta x plus the next 3x delta x squared, and the last term plus delta x cubed. So when you expand this, right, the first term x square that will get cancelled with this 2x square, leaving the other terms. So I'll give 4x delta x plus the last term delta x squared, and there will be one last term 5 delta x plus 5 delta x plus 5 delta x divided by delta x. And that's what you get simplifying this line, right? These terms. And at this stage, you should have noticed that delta x is common everywhere. So delta x is common to all the terms. So delta x will get cancelled. Hmm? This delta x, right? We can make these delta x terms disappear. Here a delta x will remain, here a delta x square will remain. This will get cancelled. Here leaving a delta x, and this delta x disappears. After that will remain, so will the delta x in the denominator. So leaving only this limit as delta x goes to 0, delta x goes to 0, this will give 3x squared, 3x squared plus, here remains 3x delta x, and this leaves delta x squared, delta x squared. This gives 4x plus 4x, and finally, not finally, two more terms. This gives a delta x, and finally plus 5. Okay. Now what happens as you take the limit? This term will disappear. Will go to 0. So will this, and this will also disappear, right? Leaving 3x squared plus 4x plus 4x plus 5. Those are the terms remaining. 3x squared plus 4x plus 5. And that's the derivative. 3x squared 4x plus 4x plus 5. And all the other terms will disappear as you send delta x to 0. And this is the derivative of this function. The derivative is 3x squared plus 4x plus 5. Okay? Okay, you can finish it. And I'll write the fourth example. The fourth is truth is fx equals square root of 3x plus 2. Square root of 3x plus 2. Hari, karagena yannako. First finish this, then you can go to the fourth example. Then ogalonta poda poda therenowane. මොකද්ද මේ කරන්නේ කියලා නේද? හරි මුලින්ම definition එක දැක්කම නිකන් මේ ඔලුවට පොල්ලෙන් ගැහුවා වගේ වෙන්නේ නැති. examples 1 2 3 කරගෙන යනකොට දැන් තේරෙනවනේ මොකද්ද වෙන්නේ කියලා. හරි බලන්න. Is the answer for this? Okay, this is what you get after substituting. Substituting in the definition. Now, in a case like this, you come across something like this. So, how to proceed from there? Do you remember in limits? In limits, we discussed a method to deal with something like this with square roots. The second method we did, when you have something like this, with these problematic terms, our method is to get rid of them. Our method is you multiply and divide everything, multiply and divide by changing the sign in the middle. Okay, so we can apply it here. You can try it there. Limit as delta x goes to 0. So we have root of 3 times x plus delta x plus 2 then minus root of 3x plus 2 divided by delta x, and at the same time we'll multiply and divide by changing the sign in this middle. That will be root of 3 times x plus delta x plus 2 plus root of 3x plus 2. And divide by the same root of 3 times x plus delta x plus 2 plus root of 3x plus 2. Right? Now the numerator here, the whole numerator is difference of squares. That's square of this minus square of this divided by delta x. And we have no problem with this, taking the limit of this, because it's plus. So we can take it separately. We'll find the limit of this part separately, and these two will be taken as difference of squares. Limit as goes to 0. So you get square of this minus square of this. So the square roots will disappear. 3 times x plus delta x plus 2 minus 3x plus 2 divided by delta x. The other part, this denominator part, we take it separately. We'll find the limit of that separately. So that'll be 1 over root of 3 times x plus delta x plus 2 plus root of 3x plus 2. Okay. And when you take this part, you see that 3x gets cancelled, so will 2. It leaves just 3 delta x over delta x. So things get simplified. So its limit as delta x goes to 0, as delta x goes to 0, that gives 3 delta x over delta x. 3 delta x over delta x, and we have taken this part separately. When you take the limit, this delta x will go to 0, this delta x will go to 0, then the two terms will be the same. When there is no delta x here, it will be 3x square root of 3x plus 2 and two such terms. Two such terms, right? So that will give 1 over 2 times root of 3x plus 2. Okay, 3x plus 2. Here delta x will get cancelled. Again, explaining that we want to find only as delta x goes to 0, right? We don't need to find see anything happening at 0. So, saying so, you can cut these delta x terms. So then that will give just 3. Okay. Finally, here it gives 3. 3 over 2. Finally, the derivative is 3 over 2 square root of 3x plus 2. This is the derivative. Okay, you see the techniques that we practiced in limits, right? They are applicable and you will need them to deal with these questions, these proofs of derivatives. Finally, the answer is 3 over 2 root of 3x plus 2. That's the derivative. Then I can write the fifth one. Have an example. The fifth, this time we are going to connect trigonometry with differentiation. It is fx equals sin x. Okay, you first finish this, the fourth, and then you can go to the fifth example, fx equals sin x. So for fx equals sin x, when you substitute in these, f of x plus delta x will be sine of x plus delta x, sine of x plus delta x minus fx is sin x divided by delta x. Okay, and now what's the next step? Once you see something like this, what's our next step? And you should remember in limits, trigonometry is connected with limits via a single theorem, right? Only one theorem we had to connect trigonometry with limits, so that is sin x over x, limit as x goes to 0, this is equal to 1. So this should come into your mind when you come across some problem like this. But the thing is, you can't apply directly here. We don't see a proof here to use it directly. Instead, we have to find a way. We have to find a way of connecting this with what we see here. මොකද කරන්නේ ළමයි? හ්ම්? මොකද කරන්නේ මේ වෙලාවට? So you should remember, seeing this something like this, suddenly you should remember the formula. The formula, we learned the formula in trigonometry in order to apply in situations like this, should within a flash should come into your mind the formula sine C minus sine D, sine minus sine, right? So we'll apply that and see what happens. If you did so, can you show the answer? What do you get for if you finish this? What do you get? The derivative of f dash x. What is your answer? Karupa ek penan para? Kian balan maka jawab tadi. Somebody finished it. Let's see. So sine minus sine is 2 plus sine. You add and divide by 2. When you add, that will be x plus x, 2x divided by 2. That will be x plus delta x divided by 2. Okay, you add these two and divide by 2. You will get x plus delta x over 2. Then you subtract and divide by 2. When you subtract, x will cancel off, giving delta x over 2. Right? Sine of delta x over 2. D divided by delta x. Okay, now we see like we have a chance of applying the theorem here. Some signs of the rule here, right? So it's sine of delta x over 2. We can take it together with delta x. We can take that part separately. Sine of delta x over 2 over delta x. But to apply the rule, it's not just delta x we need. If it is sine of delta x over 2, should be divided by delta x over 2. But here there is a 2, the numerator, like you can borrow it. You can send it to delta x divided by 2. So you don't need to take it from outside, right? You don't need to import it. You can use this 2 as delta x over 2. And then this part will remain cos of delta x, cos of x plus delta x over 2. So I'll take it separately. This cos term I'll take separately, and the sine part again separately, right? Right. So we take this part separately, right? Uh, so limit as delta x goes to 0, cos of x plus delta x over 2 into a sine of we'll take separately limit as delta x goes to 0, sine of delta x over 2. We need delta x over 2, so we'll take this 2 there and write delta x over 2. Right, and further we need it's not just delta x, some adjustment we need. Now it's like most of the things are already set. Further we need delta x over 2. Further we need delta x over 2 here. But what happens to delta x over 2? Delta x goes to 0. Then delta x over 2 will also go to 0. So you can replace delta x goes to 2. You can replace by this. Right. Then හැමදේම අපිට ඕන විදිහට තියෙනවා. Now this by the theorem this gives 1. As delta x goes to 0, this gives just cos x. It's just cos x. So finally it's cos x into 1. It's cos x into 1 into 1. So it will be equal to cos x. It will be equal to cos x. So you differentiate sin x. So see the beauty. In mathematics, as I always say, right? The sin function, you differentiate sin x. As the result, you get cos x. F dash x equals cos x. So I tell you always there are nice patterns in mathematics. This is a good example, right, of nice patterns in mathematics. Okay, අඩුපාඩු තියෙනවා නම් ලියා ගන්න ළමයි. Right. අපි මෙහෙම කරමුද ළමයි? අද ඔය දවස් නිසා වෙන කටියත් අඩුයි. මම homework වලට මෙන් තව එකක් දෙකක් දෙන්නම්. You can try them. And we can stop the class. With that, so I'll give for homework to find f dash x. I'll give 1 or 2 for homework for you to practice. Homework. To find f dash x, if number 1 fx is equal to 1 over x, number 2 fx is equal to 1 over root x, number 3 fx is equal to sine of 1 over x. This is for homework. Right? අපි එහෙම කරමු ළමයි. අද කට්ටියත් අඩුයි. ඒ නිසා මේක ඉතුරු ටික අපි ඊළඟ දවසේ වුණොත් ටිකක් වැඩි වෙලා අරන් අනිත් තර්ස්ඩේ නේ ටිකක් වැඩි වෙලා අරගෙන හරි ඉවර කරමු. එහෙනම් මේ ටික ලියා ගන්න homework වලට ඔයගොල්ලෝ ගණන් ටික හදලා තියන්න. යොතනින් අවසන් කරමු ළමයි. හැමෝටම බුදු සරණයි. අද පොයේ දවසේ නිරෝගී සුවය ප්‍රාර්ථනා කරනවා.